variables. The first method for solving equations with two variables is to draw the graphs. The equations that we're looking at right now, they are lines. So if we draw the graph, and we get two lines, and let's say they look like this, and that they intersect at this point right here, we'll say this is 3, 1. So if you were to draw the graphs on a graphing calculator or by drawing the lines yourself, and they intersect at one point, this is your solution, right? This tells you where they intersect, tells you what x and y are. So this would tell you that the solution to this set of equations is x equals 3 and y is equal to 1. Because the point where they intersect, the x value is 3 and the y value is 1. Okay, so if you have a solution, that means the graphs are intersecting at that point. Now, let's say you draw the graph of both equations, and when you draw them, they end up being parallel lines. You draw both equations, and they're parallel lines. Where do those intersect? Where do parallel lines intersect?
They don't.
They don't. So what's going to be the solution then? No solution, right? If they're parallel lines, there's no points they have in common. So then there will be no solution. And then the last situation you could run into is that if you draw your graphs of your lines, you draw one line on a graph or you graph it on a calculator. And then you go to draw the other one and it lands right on top of this one. Over here, these two lines had only one point in common, 3, 1, and that was the solution. Over here, these two lines had no points in common. Over here, how many points do these two lines have in common?
4.
I think more than 4 even. Because I think they have this point in common. I think they have this point in common, 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 this point in common. Could I keep going? How many points do they have in common? Infinitely many, right? As many points as we possibly could draw forever and ever, right? As this line goes on. So how many solutions does this have then? Infinitely many solutions. This has infinitely many solutions. And this is when it's the same line. Now, I'm not going to make you draw graphs of lines. You've done that before in Algebra 2. You can do it on the big fancy graphing calculators. You've done that in Algebra 2. I'm not going to make you draw them, but I could give you a graph and ask you what the solution is from a graph, right? So you do need to know what these graphs mean, okay? So if they intersect, then there's one solution, and it's the point where they intersect. It's the x value and the y value. If they're parallel and they do not intersect, then there is no solution because they don't have any points in common. And if they are the exact same line, then that means there are infinitely many solutions because they have infinitely many points in common. So graphing is the first method for solving systems of equations. I'm not going to make you graph, but you do need to know what that looks like. Okay, so that's not really the method we're going to focus on. Okay, we're going to focus on two other methods, substitution and elimination. I think as soon as we start doing them, they'll ring a bell for you from Algebra 2. So, substitution method, you're going to look at any set of equations and you're going to pick substitution or elimination. Okay, and how do you know which method to use? Well, the way that we usually pick substitution is if one of the variables is already solved in one of the equations and it's already by itself. Usually that variable is y, okay? So if one of the variables, or if y is already by itself, So if one of the equations is already solved for one of the variables, usually it's y. Okay, it could be x as well. If not, you can solve using substitution by making one of the equations solve for one of its variables, right? So solving one of the equations for y or x. But usually if you have to do that, it's going to be better to just turn around and use elimination instead, okay? So take a look at these two equations here. If I'm going to solve this set of equations, which one of these equations already has one of the variables by itself? The first one or the second one? The second one. Y is already by itself, right? So this is going to be a good candidate for substitution. Is this a good candidate for substitution as well? Yeah, is there already one of the equations that one of the variables is by itself? Yeah, down here, y is already by itself, okay? So that's when you're going to want to use substitution. So how do we use substitution? Well, once one of the equations is already by itself, you're going to take the first equation. We're going to write down 3x minus 2y, except we're not going to put the y in there. So we're going to take this equation, and we're going to fill in for this y right here. What do we all know that y is equal to in the other equation? What does y equal? 3 minus 5x, right? So what am I going to, I'm going to take this and I'm going to substitute, this is why it's called substitution, that in for that y, right? So we're going to take 3 minus 5x because that's what y is equal to, and we're going to put it in here for y. We're going to put it in parentheses because we're multiplying that 2 by y. So we're going to put 3 minus 5x in here, and it's still equal to 7. So we're taking what y is equal to, and we're substituting it in there for that y. And now what we've done is we've created an equation with one variable, x. So this is going to be easy to solve, but we do have to do a couple steps. So what do I do first with this 2? Distribute or multiply. Just remember it's a -2, so take the negative with it. So do -2 times 3, and we'll get -6. Do -2 times -5x, and we'll get positive 10x. We still have our equal 7, and we still have the 3x in front. And now we'll go ahead and start solving for x, but what can I do on this side since there's a 3x and a 10x on the same side? Combine those like terms. 3x and 10x, so those will combine. You're not going to subtract 3x. You're combining 3x and 10x. Those add together to be 13x. And then -6 doesn't have anything to combine with on that side. You can't combine it with the 7 because it's not on the same side. And now that we have all the like terms combined on this side, then I can go ahead and start solving. So we'll add 6. And you'll have 13x is equal to 13. And then we'll divide by 13. And we'll get x equals 1. At this point, have I solved and found the solution to these equations? No, I found half of it. What half did I not find? Y. I found x, but I need y and x because there's 2 equations and 2 variables. So how can I find y?
Plug x in.
Yeah, plug x in. It doesn't matter what equation you plug it into. You can plug it into either one of these. I usually just pick the one that's most simple or has the least numbers. Specifically this one here, since it's already y equals, it'll be easier if we plug it in there. So I'm going to plug it into the second one, but you could plug it into the first one. So I'm going to plug in 1 here, and you'll have 3 minus 5, because 5 times 1 is that, and so y is equal to -2. So here our answer, you're going to see it written in 2 different ways. Sometimes you might see it x equals 1 and y equals -2. But most of the time you'll see it written as a point, 1, -2. So these are the 2 ways that you're going to see the answers written. Usually we're going to write it as a point. Because remember, because there's a solution, that means we have two lines that intersect if we were to draw these on a graph, and the point where they intersect is the point 1, -2. That was not a very good drawing on a graph, but I'm just trying to remind you that these are two lines that intersect at the point 1, -2. Any questions on that one? Okay, let's look at this example here, number 2. Is this a good candidate for substitution? Is there already one that's by one of the variables already solved by itself? Yes. Yeah, the second one. So take that one and plug it into the first equation. I want you to do that step on your own. Take the y here and substitute it into the first equation for y. And then I would like you to try to simplify. So you're going to take 3x minus 8 because that's what y equals, and you're going to plug it in here for y. So you should have 3x minus, put it in parentheses because you've got to subtract the whole thing. 3x minus 8 equals -2. Then go ahead and distribute and combine like terms. What am I distributing here? A negative or a -1, right? There's a little invisible 1 here. So you can either think about distributing the negative or the -1. So you should end up with 3x minus 3x plus 8. Then if you haven't already, go ahead and combine your like terms. What do I get when I do 3x minus 3x? I combine those like terms. 0x. And what is 0 times x? 0. So you could also say that's just 0, right? 3x minus 3x is just 0, or they cancel out, right? Because they become 0. And 0 plus 8 is 8. So what happened to your x's? They disappeared. So how are you supposed to solve for x if they disappeared? You don't. You can't. They disappeared. But we've run into this situation before when they've disappeared, and we've had to ask ourselves a question. Anyone remember what we asked ourselves about this equation? Is it true? Is 8 equal to -2? Absolutely not, right? So is this true or false? False. Anyone remember what we say when it's false? No solution. This is exactly the situation where you have parallel lines. This is no solution. So if you were to draw these lines on a graph, they would be parallel. So if your x's disappear and your equation is false, you say no solution. What if, though, our x's disappeared and it said 8 equals 8? Would that be a true equation? What would we say then? What was our other? There was one solution, no solution, and what was the third situation? Yeah, everything. So it was either one solution, no solution, or they're the same line and there's infinitely many solutions, right? So if your x's disappear and you get an equation that says 8 equals 8, it's not no solution anymore. That's a true equation. So then it's infinitely many solutions, right? Okay. Any questions about number 2? All right, let's go talk about elimination method. if you take a look at these two sets of equations, are any of these variables by themselves already? No, you've got m's and n's on both sides. Are any of these variables by themselves already? No. So these are going to be situations where you're not going to use substitution. You're going to use elimination instead, okay? With elimination method, your goal, I think you'll remember this once we talk about it. Your goal is you want to look at the same variable, and you want the variables to have the same number in front, so the same coefficient, but opposite signs. So right now, these two do not have the same number in front, but do they have opposite signs? Do the m's have opposite signs? Yeah, top one's positive, bottom one's negative. Do the n's have opposite signs? No, and they don't have the same number, right? What would you multiply the bottom one by to get the same number, though? 2. And if we wanted opposite signs, you would multiply by -2, right? So one option is to multiply this whole bottom equation by -2. However, instead, what we're going to do, you can do it either way, doesn't really matter. What could I multiply this m by so that these are the same number and opposite signs? Just 3, because they already have opposite signs, right? So what we're going to do is we're going to multiply the bottom equation by 3 so that the m's have the same number and the opposite sign, okay? So first, we're going to rewrite the first equation on the top because we're going to keep that one the same. So I'm just copying down the first equation on the top. We're going to keep that one the same. We're not going to touch that. And then we're going to multiply the second equation by 3. Every part of the equation, not just this. We got to multiply the whole equation by 3, both sides, to keep it the same equation. So we'll get -3m. 3 times 2 will make this part what? 6n. And then 3 times 2 will make the number on the other side 6. Welcome, Alex. And once one of the letters has the same number, opposite signs, then you're going to draw a bar underneath. Thank you. And you're going to add the equations together, kind of like an old school addition problem from elementary school. You're going to add the m's together, the n's together, and the numbers on the side, and you're going to put an equals here. You're going to still have, you're going to combine these into one equation. So what happens when I do 3m plus -3m? That disappears. It becomes 0. If you want to let it disappear and not put anything there, you can just let it disappear. If you want to remember that it's 0, you can put a 0 there. It's totally up to you whether you want a 0 or just let it be empty. What's 4n plus 6n going to be? 10n. And then 24 plus 6 will be 30. And now what we've done is we've created an equation with how many variables? How many variables are now in this equation? 1. So now can you solve that equation? Yes, very easily. 0 plus 10n is 10n. Divide by 10. And you get n is equal to 3. Am I done? Did I find the solutions to this equation? No. What do I still have to find? We found n. We still need m, right? So pick one of your equations. It can be any of these equations that you plug n back into. I like to pick the one with the least numbers. So this one to me looks the most simple. It has the least numbers, so it just means less work. So I will plug it into the second one. So we'll have -m plus 2 times 3, because we're plugging in 3 in for n, equals 2. But you can plug it into any of the equations. It doesn't really matter. I just like to make my life easier, so I pick the most simple one. So this will be -m plus 6 is equal to 2. We'll subtract 6. We'll get -4. And then there's a little invisible -1 in front of the m, so we'll divide both sides by -1. And we'll get m is equal to 4. So our answer here we might see it written like n equals 3 and m equals 4, or we'll usually see it written as a point, 3, 4. Because remember, this means that we have two intersecting lines and their intersection point is at 3, 4. Any questions on this problem? Yeah. Doesn't really matter. You honestly could assign either one. It would just be like whichever one you're putting on the, you would put n on the x-axis and m on the y-axis, or you could flip them. Graphs will look a little different, but they'll still intersect at the same point. Yep. So you could have done it the opposite, 4, 3. Okay, so now let's look at number 4. Are any of these variables by themselves? Should we use substitution on this? No, none of those variables are by themselves, so we're going to use elimination. So I want you to make either the x's have the same number in the opposite sign, or the y's have the same number in opposite sign. Multiply one of those equations by a number to make either the x's have the same number in opposite signs, or the y's have the same number in opposite signs. What would I multiply by the top equation if I want them to have the same for the x's? 2. This already has opposite signs. What about for the y's? You could also multiply the top by 2, right? So for this one, it doesn't really matter which one you do, but we're going to multiply the top by 2. So if you do that, you'll get 6x minus 8y is equal to 24. Copy down the bottom equation. Again, your goal is to get the same number, opposite signs for one of the variables. It doesn't have to be for both, just one. And then go ahead and add your equations together and write down what you get. What's 6x plus negative 6x going to give you? 0. What's negative 8 plus 8 going to give you? 0. What's 24 plus negative 24 going to give you? 0. So then what's 0 plus 0? 0 equals 0. What happened to my x's? Or my y's? Everything disappeared, right? So, is this equation true or false? True. This one's true. The last one was false, but is 0 equal to 0? Yes, so this is a true equation. So how many solutions are there now? Infinitely many solutions.
Can we put all our numbers?
Yes. Well, no. Those are not the same thing. Because there are infinitely many answers, but not every combo is an answer. Does that make sense? So like 1, 2 may not be an answer, right? But there are just infinitely many. Does that make sense? So in this case, those are not the same. Yeah. So not every single possible, like if you plug in 1, 2 into this, you'll get 3 minus 8, and that's not going to give you 12. Does that make sense? But there are just infinitely many combos that you can plug in that will make it true. So if we're looking at a graph, this would be that case where you have there the same line, right? There, if you were to graph them, you would graph them right on top of each other, and this would be the same line. That's why anything you plug into this equation, plug it into the other equation, it will make that one true as well. Any questions about number 4? All right, so that's it for today, is substitution and elimination. Those are 2 methods we're going to focus on. I think you probably remember them from Algebra 2, so this is a nice, easy section, but we are going to do a couple word problems with them, because I know those tend to be a struggle for most people, okay? So when you're writing a word problem, how many variables have there been in all of our equations so far? 2. So there should be 2 things in your word problems. So I want you to read this problem number 5 and see if you can figure out what are the 2 things in this problem. So it might be pizza and soda. It might be people. It might be numbers. And think about the actual physical objects, not like the numbers that they're giving you. So for question 5, what are the 2 things or objects or nouns in this problem? 7 is just a number describing something in the problem. Yeah, where it just says, it literally says the word 2 right here. 2 what? 2 numbers. We have 2 numbers in this situation. Those are our 2 things. So when you figure out what the 2 things are, you're going to write X and Y, and you're going to assign them one of the 2 things. So for us, we have 2 numbers. So let's let X be the first number, and we'll make Y the second number. This problem in particular, some of you can probably solve it without writing a system of equations, but I want you practicing writing a system of equations to describe the situation, even if you can find the answer without it, okay? Because not everyone will let you do that. And now what you're going to do is you're simply going to read the sentences, and you're going to create 2 equations, because if we have 2 variables, we need 2 equations, and it literally will be so easy to write the equations from these sentences. You literally just read the sentence. So our first sentence says, the sum. What does sum mean? Add the sum of the 2 numbers is 7. So how can I make an equation out of that? The sum, so what are we going to do? X plus Y, the sum of the 2 numbers, add them together, and we should get what? 7 is 7. You literally are reading the sentence. The sum, okay, add the 2 numbers. What are our 2 numbers? X and Y is 7, equals 7. Now read the next sentence. This gives us our second equation. If one number is subtracted from the other number, the difference is -1. Write me down an equation right here for that sentence. If one number is subtracted from the other number, their difference is -1. So what are you going to do with your X and Y, your numbers? X minus Y equals what? -1. Okay? As simple as that. You're literally just reading the sentences to write your equations. Now we pick either substitution or elimination. Are either of these already by themselves? No. This would not be a terrible one to do substitution because it'd be easy to solve for one of the variables, but I still find elimination easier. When you do elimination, you want the numbers to be the same number, opposite signs. What number is in front of both of these X's? 1. Are these already the same number? Yes, but are they opposite signs? No. How about the Y's? What number's in front of those? 1. Are those opposite signs? So do we have to do anything? No, nothing is needed. It's ready to go. So just add them together. X plus X will give me what? 2X. Y plus -Y will go away or give me 0. So either leave it blank or put a +0 there if you want. That's personal preference. And then 7 plus -1 will be 6. Now can I solve that equation? Most definitely, because there's only one variable. So 2X is equal to 6. I'll divide both sides by 3. Or I'm sorry, by 2 to get 3. Am I done? No. Plug it back into either equation. Doesn't really matter which one. They both don't have very many numbers in them. I'll plug it into the first one. 3 plus Y is equal to 7. Subtract 3 from both sides, and you get Y is equal to 4. So here our 2 numbers are 3 and 4. Because it said the sum of your numbers is 7, and when you subtract 1 from the other, you get -1, which 3 and 4, when you add them together, you get 7. Subtract 4 from 3, and you get -1. Now, this problem is not that hard. Some of you probably could have figured out that it was 3 and 4 without having to write down the equations, but I want you practicing writing down the equations because it won't always be that easy. Any questions about that one? All right, the next word problem, I want you to read it and figure out what are your two things. And then you should assign one to X and one to Y. So read the problem and figure out what are your two things. What are our two objects in this problem? Fudge and bubble gum. We do have Chase and Sarah as well, but they give us a lot more information about the fudge and bubble gum, right? So fudge and bubble gum are our objects. So let's make X fudge, and we'll make Y bubble gum. And then you're going to read your sentences and create two equations because you have two variables. First sentence says Chase and Sarah went to the candy store. Can I make an equation out of that? Are there any numbers there? No, that's not helpful. They just went to the, that's just description. Now, second equation, Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. How can I make an equation out of that?
5 plus 3 equals.
So we're actually going to do 5 times the fudge first. Since X is the fudge, that's going to be the cost of the fudge, right? So we're going to do 5 times X, since that's the fudge, because we need our X's and our Y's in there. Plus, how many bubble gums did he buy? 3Y equals 570. Because if he buys, let's say each piece of bubble gum is 50 cents, right? Multiply that by 5, and that's how much money he spent on bubble gum, right? Or fudge. And each piece of bubble gum is 10 cents. Multiply that by 3, and that's how much he spent on bubble gum. Now, read the next sentence and give me another equation right underneath that. So read the next sentence to yourself and write down your second equation underneath. Sarah bought 2 pieces of fudge and 10 pieces of bubble gum. And her total was $3.60. So that should be your second equation. Any questions about how we wrote the equation? Okay, now I want everyone to pause and pay attention for this one because I'm sure 50% of you are going to ask me a question about a problem like this. So put your phones down and pay attention. I need the moment. Okay, sorry. Did not pay attention for 5 minutes. I need the same number, opposite signs. Do the X's have opposite signs? No. Do the Y's have opposite signs? So you're going to have to multiply by a negative at some point, right? To get opposite signs. Can I multiply 2 by a number to get 5? No. Can I multiply 3 by a number to get 10? So am I just stuck? No. How can I get the same number here?
You can multiply them by each other.
You can multiply them by each other, right? If there's not one, if you can't multiply one equation by one number, we would do that. That would be the best, right? Because that's less work. But if you can't, you have to multiply both equations by a number. And if you just pick the other number, then you know you'll get the same number, right? Because if I multiply 5 by 2, what number do I get?
10.
And if I multiply 2 by 5, what number do I get? 10. But we need them to be opposite signs. So one of them is going to have to be a negative, okay? So let's multiply the top equation by -2. You can do the bottom one by -5 if you want. It doesn't really matter. Just make sure one of them is positive and one is negative so they have opposite signs. So we'll multiply. You could do 10 and 3 as well, but 5 and 2 just give us smaller numbers. So that's why I picked that. You could do 30 for these two. That would be no problem, okay? So now let's do that, and let's write the equation over here next to it. So -2 times 5 will give you -10x. -2 times 3 will give you -6y. And then -2 times 570, you'll probably have to type that into your calculator. That should give you -11.4. 5 times 2x will give you 10x. 5 times 10y will give you 50y. And 5 times 360, you'll probably have to type that into your calculator. You should get 18. Then I want you to go ahead and add your equations together. Yeah. When you add, the x's will go away. You can put a 0 there, or you can put nothing there. The y's, -6 plus 50 should give you 44y. And -11.4 plus 18 should give you 6.6. So then to solve that equation, you can just divide by 44. And you should get y is equal to 0.15. Then take that y and plug it into one of your equations. Doesn't really matter. It could be any of these four. Just pick an equation that has x and y in it. There's not really one that's ideal here because they all have lots of numbers. And then solve for x. So go ahead and do that part. So I went ahead with the first equation. But you'll get the right answer either way. So I got 5x plus 0.45 when I did 3 times 0.15. Then I subtracted 0.45. And I got 5x is equal to 5.25. Divide by 5. And I got x is equal to 1.05. So each piece of fudge cost $1.05, and each bubble gum cost 15 cents. Makes sense. Fudge is a little more expensive than bubble gum. All right, we have just about 10 minutes till the end of the period, so I'd like you to flip it over. And there are 3 problems on the back I would like you to try. For the first 2, I want you to pick which method you should use, substitution or elimination. If you are unsure, make sure to ask me before you use that method, okay? There should be one of each. So I want you to do 1 substitution, and one elimination.